Hello all, this is Karthik from Sri Venkateshwara College of Engineering uh, from CSEI branch. Today our topic is image sensing and acquisition. So after completion of this video or before completion of this video, you will be able to get what is meant by image acquisition, what image acquisition using single sensor and image acquisition using array sensor and image acquisition using sensor strips. Instead of going to all these things, we'll just learn what is meant by image acquisition. We'll just learn the basic meaning of acquisition. So image acquisition can be defined as the act of procuring an image from sources. It's an act of procuring image from sources. This can be done via hardware systems such as cameras, encoders, sensors, etc. This can be done by hardware systems such as cameras, encoders, sensors, etc. Irrefutably, it is the most crucial step in the MV workflow because an inaccurate image will render the entire workflow useless. It's an important thing. Image acquisition is an important thing actually. So the types of images in which we are interested are generated by the combination of illumination source and the reflection of or absorption of energy from the source by the elements of the scene being imaged. The illumination may be originate from a source of electromagnetic energy such as radar, infrared or X-ray energy. This can be originated from electromagnetic energy such as radar, infrared or X-ray energy. Illumination energy is reflected from or transmitted through objects. Illumination energy generally reflects from or transmitted through the objects. An example in the first category is light reflected from a planar surface. It's an example. Incoming energy is transformed into voltage by combination of input electrical power and sensor material. This is responsive to particular type of energy being detected. The output voltage waveform is the response of sensors, and digital quantity is obtained from each sensor by digitizing its response. In this section, we look at principal modalities for image sensing and generation and image acquisition. Three principal sensor arrangements used to transform illumination energy to digital images. There are three sensor arrangements used to transform illumination energy into digital images. What are they? There are three, right? So the first one is single image sensor, and the second one is line image sensor, and third one is array sensor. So incoming energy is transformed into voltage by the combination of input electrical power and sensor material that is responsive to the particular type of energy being detected. The output voltage waveform is the response of the sensors, and digital quantity is obtained from the each sensor by digitalizing its response. And we'll get to know about types of sensors. So the image is given here, so you can go through that for the clarity. Image acquisition using single sensor. So this one is the first method. The components of single sensor, perhaps the most familiar sensor of this type is the photodiode, which is constructed from silicon materials and whose output voltage waveform is proportional to light. The use of filter in front of sensor improves selectively. We will go through this once more time. Like the components of single sensor, perhaps the most familiar sensor of this type is photodiode. The most familiar sensor of this type is photodiode. The example, which is constructed from silicon materials. It is constructed from silicon materials and whose output voltage waveform is proportional to light. The output voltage waveform is proportional to the light. Use of filter in front of sensor improves selectivity. If you use a filter in front of sensor, the selectivity will improve. For example, a green pass filter in front of light sensor favors in the light of green band of the color spectrum. So if you use a green band filter in front of a light sensor, so it favors. As a consequence, the sensor output will be stronger for green light than other components in the visible spectrum, and the image is given here. And the second image acquisition using single sensor. Example of single sensor is photodiode. Now to obtain 2D image using a single sensor, the motion should be in both xy direction. If the motion is in both xy direction, we can obtain 2D image using single sensor. Rotation provides motion in one direction. Linear motion provides motion in perpendicular direction. Linear motion provides motion in perpendicular direction. This is an inexpensive method, and we can obtain high resolution images with precision. This is an inexpensive method, and we can obtain high resolution of images with precision. Image acquisition using array sensor. The individual sensor arranged in the form of 2D array, numerous electromagnetic and some ultrasonic sensing devices frequently are arranged in array format. So individual sensor arranged in 2D array, numerous electromagnetic and some ultrasonic sensing devices frequently are arranged in array format. This is also the predominant arrangement found in digital cameras. This arrangement is also found in digital cameras. A typical sensor for these cameras is CCD array, which can be manufactured with broad range of sensing properties and can be packaged in rugged arrays of elements and more. So we'll go through this once more time. A typical sensor for these cameras is CCD array, which can be manufactured with broad range of sensing properties. That can be manufactured with broad range of sensing properties and can be packaged in rugged arrays of elements or more. CCD sensors are used widely in digital cameras and other light sensing instruments. CCD sensors are used widely in digital cameras and also in light sensing instruments. This one is the last method we are going to discuss now. The last method is image acquisition using sensor strips. So we'll go through that. A geometry that is used much more frequently than single sensor consists of inline arrangement of sensors in the form of sensor strips. A geometry that is used more frequently than single sensors consists of an inline arrangement of sensors in the form of sensor strips. These strips provide imaging elements in one direction. Motion perpendicular to the strip provides imaging in other direction. This is the type of arrangement used in most flat bed scanners. Sensing devices with 4000 or more in line sensors are possible. And thank you. This is about image acquisition. Thank you once more.